In this video, we'll talk about some advanced memory management techniques used by hypervisors. First, let's look at the concept of overcommitment. Just like virtual memory, virtual machine monitors or hypervisors can allocate more memory to guest OSs than is physically available on a system. In this example, we have a hypervisor and 3 different VMs. Now, the hypervisor only has 4 gigabytes of memory available, but we have allocated 2 gigabytes of memory to each of the VMs. Now, this is possible, but you have to have advanced techniques to reclaim memory when needed, especially when there is pressure on the memory. So we'll look at 2 advanced techniques that are employed by VMware's ESX hypervisor. The first is the transparent page sharing technique. This is supported in ESX. Now, if there are multiple instances of a guest OS on a machine, then there may be pages that are exactly identical across guests. Typically, these are pages that belong to the OS or the OS kernel that are, in read-only mode that don't get modified often. So it doesn't make sense to keep multiple copies of these pages across the host memory. So in this example, we can see 2 types of pages, green and orange, both of which are identical. And VMs 0, 1, and 2 share the green page on the host memory. VM 1 has a page that is colored in orange, which is identical as VM 2, but currently it's allocated a duplicate page which needs to be removed. So in the transparent page sharing technique, ESX will periodically scan memory pages to detect duplicates, and it will keep only a single physical copy of the page in memory. So ESX does this by keeping a hash table of all of the memory pages, and it calculates the hash of the page content. And if it matches with an entry in the hash table, then it will replace the reference to that page to that particular page that is in host memory. Now, if a page is dirtied, then ESX can fork a new copy of the page using the copy on write technique. Another interesting technique that ESX uses is called memory ballooning. Guest operating systems that run on top of a hypervisor are usually not aware that they are running on top of a hypervisor. Because of this, they may not be aware of the actual memory available on the system, and they cannot detect low memory conditions. So in ESX, there is a memory ballooning technique. With this, they install a balloon driver in each guest. This is a pseudo device driver that can force guest OSs to release memory. The balloon driver pings the hypervisor to determine a balloon size. So the balloon driver would go to the hypervisor and ask, okay, what size do you want me to inflate to? If the hypervisor tells it to inflate, then it can request pin memory pages from the guest OS. So if the hypervisor tells the balloon to say, let's inflate to 1 gigabyte, then it can request for pin pages from the operating system. The balloon will inflate, and then it will have possession of those pin pages from the OS memory. Then the balloon driver can signal the hypervisor saying that those particular pages are available and free and can be reclaimed. And then these are now made available to the hypervisor for use that can be given to other VMs.